Good morning, students. Am I audible to you?
Yes, sir.
Okay. Good morning.
Good morning, sir.
So today's topic is reverse the rotation. Today's topic is reverse the rotation. Reversal of rotation. Suppose a motor is rotating in clockwise direction, but we have to rotate it in anti-clockwise direction. What we have to do? Suppose we have a shunt motor. Suppose we have a shunt motor and it will rotate in clockwise direction. So, or you can write here in. Suppose a sun motor is rotated in clockwise direction, but we have to rotate in anti-clockwise direction. So what is the procedure or what are the methods by which we can reverse the rotation of a DC motor? So first tell me what is the torque equation. Tell me what is the torque equation. एक मोटर क्लॉकवाइज में घूम रहा है उसे हमें एंटी क्लॉकवाइज में घुमाना है तो हम क्या करेंगे पहले टॉर्क इक्वेशन बोलिए क्या है टॉर्क इक्वेशन खुशबू व्हाट इज द टॉर्क
Yes,
इक्वेशन
sir.
मनीष
Yes, sir.
के फाइव आई
I, I.
गुड एंड नाउ टेल मी व्हाई ए मोटर इज रोटेटिंग मोटर एक घूमता क्यों है ये बोलिए एक मोटर घूमता क्यों है व्हाट इज द रीजन बिहाइंड इट व्हाई ए मोटर इज rotating in particular direction say it may be clockwise or maybe anti-clockwise why a motor will rotate घूमता क्यों है
Sir, it experiences torque.
say again
Sir, it experiences torque.
good though the armature experiences torques that's why the rotor or say armature will rotate in a particular direction that means the reason behind the rotation of a DC motor is the torque So if we reverse the direction of the torque, then the rotation will also be reversed. That means if we create the reverse torque than the previous one, then we can change the rotation of a DC motor. So we can modify the torque equation is like that. Suppose we have a torque, due to the torque, the rotation is in clockwise. So we have to create another torque, or say the opposite torque, say it denoted by T dash. So the direction should be in counterclockwise. That means T equal to minus T dash. T और T dash का value opposite होना चाहिए. We know from the top equation T is equal to K phi into Ia. So if we replace the value of phi by If, we can modify that equation as T is equal to K dash If into Ia. So tell me, if I want to make the negative sign, that means we have to make the negative sign of torque. What should we do at that time? What we should do? ios
सर वोल्टेज पोलैरिटी रिवर्स कर सकते हैं सर?
वोल्टेज पोलैरिटी को रिवर्स करेंगे. कौन सा वोल्टेज?
सर अप्लाइड.
जो इनपुट वोल्टेज है. ठीक है,
यस
मान
सर.
लीजिए हम और एक फिगर ड्रॉ करते हैं. ये हमारा दूसरा फिगर है. और अब जो बोल रहे हैं क्या, इस पोलैरिटी को हम अगर रिवर्स करेंगे तो क्या होगा. हम ये पोलैरिटी को रिवर्स कर दे रहे हैं, मतलब ये ऊपर नेगेटिव होगा और नीचे प्लस होगा. If we change the polarity of the supply voltage, then the upper terminal gets the negative value and the lower terminal gets the positive value, and the direction of the current will also be changed, because we know that the direction of the current is always from positive terminal to negative terminal. So we have to change the direction of the current. ऐसा होना चाहिए.
यस
आयुष,
सर.
ऐसा होना चाहिए. Yes or no?
यस सर.
Then मान लीजिए आप क्या किया, ये नया टॉर्क क्रिएट कर रहे हैं. आप टाउ डबल डैश ले रहे हैं हम इसे, तो उसका वैल्यू क्या है, के डैश. अब देखिए वो जो फील्ड करंट है उसका डायरेक्शन रिवर्स हो गया, मतलब हम उसे माइनस आई आई एफ से डिनोट करेंगे. दो द डायरेक्शन ऑफ द करंट change now, so we have to represent it by the minus if. And in case of armature current, what we should write? Ayush, what we should write now?
minus IA.
Minus IA. That means if we simplify this equation, what is the final form? This is the final form. That means it is equal to the T,
तो उससे टॉर्क का डायरेक्शन चेंज नहीं हो रहा.
मतलब टॉर्क का डायरेक्शन चेंज नहीं हो रहा है. तो क्या मोटर क्लॉकवाइज ही घूमेगा कि एंटी क्लॉकवाइज घूमेगा?
तो क्लॉकवाइज ही घूमेगा.
क्लॉकवाइज घूमेगा. तो आप बोलिए आप क्या करना है? हमें अगर रिवर्स डायरेक्शन में घुमाना है. So what should we do now to change the direction of the rotation?
सर IF और IA का करंट अपोजिट कर देंगे डायरेक्शन. तो
दोनों का ही कि एक का?
किसी एक का, मतलब दोनों का
किसी
एक
एक
प्लस
का.
होना चाहिए, एक
गुड.
माइनस होना चाहिए.
Good. That means we have to change the direction of current. Say, if we change the direction of the field current, at that time the armature current should be in the previous direction. Or say, either we have to change the direction of field current or the direction of armature current. That means to change the direction of rotation, we have to change either the direction of field current or armature current. That means we have to change either the direction of field current or the direction of the armature current. But we don't have to change the direction of field current and armature current simultaneously. We have to change either the direction of the field current or the direction of the armature current. हमें सिर्फ फील्ड करंट और आर्मेचर करंट का ही डायरेक्शन चेंज करना है, कोई एक का, लेकिन बोथ का नहीं. If we change the direction of the current of field and armature in simultaneously, or say in we change both cases, or say both current, so at that time we get the same torque. That means the direction of the motor will not reverse. So if we now we create a torque d dash and change the direction of the only field current. So what we get? Minus k dash if into ia. So this is basically minus t, and suppose if we change the direction of, suppose if we wait a minute, Suppose if we change if we change the direction of the armature current, we change the direction of the armature current, then we also get minus T. Ayush, Khushbu, Manish, Deepak,
Yes, sir.
have you understood?
Yes, sir. Yes, sir.
Okay. That means either we have to change the direction of the field current or we have to change the direction of the armature current. But same time we don't do the change the direction of both. That means if we change the both direction, then the torque will as like the similar or the previous one. So for shunt motor, first we change the direction of field current. This is IL and the direction of the armature current is like the previous one, but we have to change the direction of the field current. So we have to change the terminal of field current. Say suppose this is F1 terminal and suppose this is FF terminal. Because in previous one, suppose this is F terminal and this is FF terminal. And suppose this is A terminal and this is AA terminal. Similarly here this is FF and this is F, this is A and this is AA. So what we have to do now? Ayush, tell me what should we do now? अब क्या करना है हमें? करंट को चेंज करना था. पहले किस तरफ जा रहा था करंट? डाउनवर्ड वाला. मतलब the direction of the field current in previous one, in case of previous one, it is downward. But we have to change it in upward. So what we should do now?
सर फील्ड कॉइल का टर्मिनल रिवर्स कर देंगे.
कॉइल का टर्मिनल का हमें रिवर्स करना है. मतलब ये जो F पहले किसके साथ कनेक्शन हुआ था? पॉजिटिव या नेगेटिव?
पॉजिटिव.
पॉजिटिव के साथ था. अभी इसे नेगेटिव के साथ जोड़ देना है. और पॉजिटिव को इसके साथ जोड़ देना है. तो आप what is the direction of the current? Now the direction of the current is upward and the direction of the shaft should be in, now it should be in counterclockwise,
and
that means
anti-clockwise.
anti-clockwise. Have you understood? Ayush, Manish, Deepak, Kushbu.
Yes, sir.
Now the next diagram is for, we have to change the armature current direction. Should be plus, should be minus, this is equal to, this is field coil. The direction of the current to the field is now downward. This is the direction of the IF, and we have to change the direction of the current so that the rotation will in reverse direction. So we have to connect like that. This terminal is A and this terminal is A. This is A. This is A. This is F. This is F. So what is the direction of the armature current is now? Which, in which direction? It is it is in upward or downward? The direction of the current. What is the direction of the current of armature now? Upward or downward?
Upward, sir. Upward.
So the torque generated in these both cases are opposite from the previous one. So the rotation of the shaft is now in reverse direction than the previous one. Have you understood?
Yes, sir.
So tell me what should be the diagram for series motor. Let me first draw the first diagram for the series motor. Suppose this is normal operation, or say this is clockwise direction. Suppose in this configuration the rotation of series motor is in clockwise direction. Suppose this is F terminal and this is FF terminal, and this is suppose A terminal and this is AA terminal, and the direction of the current to the field is towards the left, and from armature it is in downward. This is plus, this is minus, this is V. Now So if we want to change the direction of the field current, what we should do? In first case, we have to change the direction of the field current, and in the next one, we have to change the direction of the armature current. So tell me, what should we do?
Sir, change the direction of the field coil.
The direction of the field current in this figure, this should be like the arrow, and the direction of the armature current in the last figure is like that. So what should be the connection in this figure? What should be the connection of the field terminals? We have to connect which terminal to the positive terminal? A for FF. हमें कौन सा कनेक्ट करना है टर्मिनल को पॉजिटिव के साथ? एफ या एफ एफ को?
पॉजिटिव को सर एफ को कनेक्ट कर देंगे।
पॉजिटिव को एफ एफ के साथ कनेक्ट करना है। पॉजिटिव के साथ connect। और एफ को किसके साथ कनेक्ट
विथ
करेंगे आप?
नेगेटिव से।
एफ को किसके साथ कनेक्ट करेंगे?
नेगेटिव टर्मिनल के साथ।
नेगेटिव टर्मिनल के साथ।
सॉरी सर, वो ए के साथ करेंगे सर।
ए के साथ करेंगे। गुड। So we should connect this terminal with A, so that the direction of the field current changed, but the direction of the armature current will remain same with the first figure. So here the direction should be changed from clockwise to anti-clockwise. And what about the third figure? We have to change the direction of armature current. So what should be the connection? Tell me, what should be the connection? I will
नेगेटिव साइड में सर ए को कनेक्ट करेंगे।
नेगेटिव को एक के साथ कनेक्ट करेंगे। अच्छा, तो इस नेगेटिव टर्मिनल को हम एक के साथ कनेक्ट करेंगे। फिर
और डबल ए को डबल एफ के साथ।
डबल एफ को एक के साथ। तो इससे क्या होगा? करंट का डायरेक्शन, करंट का डायरेक्शन क्या होगा?
रिवर्स हो जाएगा सर,
करंट का
डाउनवर्ड
डायरेक्शन
हो जाएगा।
कौन सा डायरेक्शन में होगा? करंट का डायरेक्शन डाउनवर्ड या अपवर्ड?
अपवर्ड सर।
Upward. That means here in the figure 3 we change the direction of armature current, and in figure 2 we change the direction of the field current. So I hope you all have understood this. समझ में आया सब? आयुष समझ में आया?
यस सर।
खुशबू समझ में आया? दीपक, आपको समझ में आया?
यस सर। हाँ सर।
खुशबू को समझ में नहीं आई? खुशबू,
सर उसका नेटवर्क खराब है।
उसका नेटवर्क खराब है, ठीक है। Now you have to connect, say you have to make the connection of compound type DC motor so that the rotation will in reverse direction. So this is your home task. Write down your home task. Write down your home task. Draw the connection. Draw the connection of compound type DC generator so that the direction of motor will reverse. So that the direction of motor will reverse. This is your home task. You have to show me that diagram in next class. फिर हमारा टॉपिक, नेक्स्ट टॉपिक is the need say starter. This is our next topic is starter. Suppose we have a device by which we can start a DC motor. That device is called starter. Suppose we are giving supply here plus minus, and from that we have to give a connection. Okay. Suppose we make a connection or say we given a supply to a DC motor like that, and the name of the device is starter. Now with the help of the device we start a DC motor, it's called starter. आया समझ में? क्या है स्टार्टर? आयुष,
यस सर।
मतलब ये एक डिवाइस है जिससे हम डीसी मोटर को स्टार्ट करेंगे, उसे कहेंगे स्टार्टर। तो मैं एक ब्लॉक से दिखाया लेकिन एक्चुअली वो ऐसे दिखता नहीं, मैं एक ब्लॉक से दिखाया। जो मान लीजिए एक डिवाइस है जिससे हम डीसी इनपुट दे रहे हैं, आउटपुट हम मोटर को देंगे, इसे ही कहेंगे स्टार्टर। दैट मीन्स with the help of the device we start a DC motor, it's called starter. So first the question is arise, why we need a starter? First question is arise, why we need a starter? हमें इसका जरूरत क्या है? कोई बोल सकते हैं?
मोटर को स्टार्ट करने के लिए सर।
हाँ, क्यों? माने मैं क्यों, मान लीजिए एक जब ट्यूबलाइट जलाते हैं हम, तब स्टार्टर लगता है, लेकिन बल्ब जलाने से तो कोई स्टार्टर नहीं लगता। So that means in the characteristics of tube light, or the starting process of the tube light and the starting process of bulb, there should be some different characteristics, so that in case of tube light we need a starter, but in case of start, or say on the bulb, we don't need a starter. So what is the actually purpose, or say what is the cause to
तो स्टार्टिंग में
use
ज्यादा
a
करंट
starter?
लेता है इसीलिए स्टार्टर लगाते हैं।
हाँ, बोलिए, बोलिए, बोलिए।
स्टार्टिंग में ज्यादा करंट लगता है इसीलिए
गुड,
स्टार्टर
गुड,
लगाते
गुड,
हैं।
गुड, गुड। स्टार्टिंग में ज़्यादा करंट लेता है, मतलब when we start a DC motor, at that time the value of the current is higher than the full load current. That means when a motor will running at full load, suppose at that time the current is say 10 ampere, but the starting current is quite high, or say very very high than the full load current. That's why, or say to reduce, or say to limit that starting current, we need a starter. That means to reduce, or say to limit that starting current, we need a starter. So first tell me what is the motor equation. First tell me what is the motor equation. Ayush, Deepak, Manish, Sumiran.
सर टी एन जेड 5/60 है।
Bnz by 60. No, this is not a motor equation. This is basically the equation of generated voltage. What is the motor equation? V is equal to EB plus
प्लस आई ए आर है।
IARA. This is the motor equation. And what is the generator equation?
ई बी इक्वल्स टू टी एन जेड 5/60।
This that one is the expression of generated EMF. This is basically motor equation. And what is the generator equation? EG is equal to V plus IARA. When we discuss the equivalent circuit of generator and motor, at that time we write these two equations. When we draw the equivalent circuit of DC generator, at that time we derive the generator equation, and when we draw the equivalent circuit of motor, at that time we derive the motor equation. So what is the motor equation and what is the generator equation? Now tell me.
So motor equation equals to V equals to E B plus I R
Good. And the generator equation is
and generate E G equals to V plus I R.
plus. This is a equation of generator, and V is equal to EB plus IRA. This is a equation of a motor. So from motor equation, calculate the value of IA. Tell me what is the value. From the motor equation, tell me the value
V
of
minus
Ia.
EB by RA.
What?
RA.
This is the equation of armature current. We can say that this is the equation of Ia. Am I right, Deepak?
Yes, sir.
Okay. So now tell me, what is the value of EB? What is the name of EB? Tell me, what is the name of the EB?
So back EMF.
Back EMF. Good. So what is the value of back EMF at the time of starting? What is the value of N at the time of starting? What is the value
So
of
0.
N? That means rotation per minute, or the revolution of the armature. The unit is RPM. What is the value of the rotation at the time of starting of a DC motor?
So almost 0, sir.
Almost zero or zero. Exact zero.
So 0, sir.
Good. At the time of starting, when just we give the supply, or say just switch on the supply of a DC motor, at that time, that means at that starting time, the value of rotation of armature is zero. So tell me, what is the value of back EMF at that time? What is the value of back EMF at that time?
So 0.
Zero. Why? You have given a right answer, but why?
क्योंकि सर N 0 है मेरा तो.
Though the expression of EB is P I N Z by 60A, so the value of N is equal to 0, so the value of EB at the time starting should be 0. So what is the equation of armature current at the time of starting?
So V by RA.
V by V by RA. Good. So we took some numerical so that you can understand it is easy. You can understand this easily. Suppose the value of V is 220 voltage, and the value of EB is 200, and the value of RA is zero point 0.5 ohm. So tell me the value of IA at rated, or say full load. What is the value of armature current at full load? Tell me. What is the value of full load current of armature for these numerical values?
40 ampere.
40 ampere. Good. And we derive by from motor equation. The value is 40 ampere. And what is the starting armature current? the value of that?
440 amperes.
440, because at the time of starting there is no back EMF. So we have to end the classes here because the time is over, because you have next class. So I'll take the attendance now. Deepak, this is time for attendance. Deepak,
Yes, sir.
Manish,
Present, sir.
Ayush,
Present, sir.
Jishan,
Yes, sir.
Praveen,
Present, sir.
Khushbu, Sumiran,
Present, sir.
Yash,
Present, sir.
Soel,
Present, sir.
Samsad,
Yes, sir.
Danish.
Present, sir.
Okay, you may leave now.
Hello, sir.